Good afternoon, everybody. How are you all doing? Good. Thank you, Anders, and thank you, Michael, for setting fantastic groundwork for the next phase. What I'm going to talk about is the interconnections between art, biology, and technology. I'm going to talk about human behaviour and our relationship between nature and culture, how we observe and adapt and co-create with nature. And time permitting and participation willing, we will conduct a live biomimicry experiment in this room. We start with the earliest known cave painting, found in Indonesia, dated to nearly 40,000 years ago. It depicts a horned mammal surrounded by the hands, stencils of human hands. Whilst we don't know the exact significance of this image or the motivation of its creator, what we do know is that the human need to visualize our world has a very, very long history. Visual representation is an inherent part of who we are and how we make sense of our world. We take a leap through time to the era where natural philosophy dominated intellectual thought. Leonardo da Vinci's sketchbooks draw comparisons between different natural phenomena. On one side, we see water eddies in a stream. The other side, the flowing growth of an old man's beard. Leonardo was not only interested in making connections between natural phenomena, he was interested in translating from one source to another. Here, his observations of the mechanics of the bird wing led to his conception of a mechanical bird, an engineering technology way ahead of its time in what was actually technically capable of at that time. This is technology adapted from nature. We take another leap through time to a more modern-day Renaissance man, Thomas Heatherwick, a British designer, engineer, general polymath. He's also looking at the mechanics of nature to seek inspiration for design. So here, a woodland fern is combined with hydraulic engineering technology to form a bridge which unfolds to let boats pass. And this is a perfect example of form meeting function whilst mimicking nature. It's beautiful and it's clever, like so many of the examples that Michael showed earlier. And through each era, technological advances have opened up new ways of seeing. The invention of the microscope, for example, enabled naturalist Ernst Haeckel to illustrate structures never before seen. Now, these are slime molds, and they are going to become important later on. Another example, developments in photographic optics enabled botanist and artist Carl Blossfeld to capture and to disseminate structures previously not being able to. So what about now? We're in an era where the fields of biology and technology are becoming increasingly intertwined. Where does that leave the artist's palette? And I'm giving you a very couple of examples. This field is huge and ever-growing. The Tissue Culture Art Project employs the latest in biotechnology processes to critique the very technology that created it. So victimless leather is an object for discussion, a means to explore what is probable, what is possible with this technology, a way of asking important ethical questions about how we could or should be using these technologies. Another example, environmental concerns are expressed through Brendan Bellinger's work. He's an artist and a botanist. His studies of deformed frogs combine ecological fieldwork, laboratory and studio practices as a way of raising awareness and affecting change. They're beautiful and disturbing. Other artists are co-creating with natural systems. So on the left, we have artist and bee colony working in collaboration to create sculptural forms. We also have artist and bacteria working together, the bacteria being encouraged to digest the photographic emulsion of these portraits. So in these examples, the artist has little control over the final outcome. They are the instigator. They set the conditions for the natural system to do its work. In my own work as an artist, I'm very interested in the meeting point between imaging technologies and biological systems. I'm interested in exploring our relationship to natural phenomena, hybrid forms between scientific method and artistic practice. And I'm interested in what we can learn from nature as individuals, as communities, as organizations, as a society. I've worked in diverse areas of science and art for many years, but there is one project that I wish to focus on today, and this is my ongoing collaboration with the slime mold, Physarum polycephalum. So, Physarum polycephalum is a single-celled organism. This means that it's made up of lots of single cells, all working together as one mass supercell. It's a superorganism. In its natural habitat, you might find it foraging on rotting vegetation in woodland, but you might just as easily find it in the laboratories of roboticists and biologists, the studios of artists and designers. Why? Because it can perform, this bag of cellular slime can perform quite high levels of computation and really efficient networking. All without any vital organs. This thing has no brain. It has no central nervous system, it has no sensory organs, it is just a bag of cells. Ecologically, we might not notice if the 700 plus species of slime molds disappeared from our natural world. They don't have a hugely important role in nature, but as a model organism, a great many people are asking different questions of this simple yet complex thing. So to introduce a few behaviours, and these will become important later on. So when it grows, when it's looking for food, it grows in nice branching patterns. When it finds food, and its favourite food is porridge oats, not in the wild, but the domesticated slime mould likes a bit of porridge. It will form tubular networks between its food sources. It's a very curious organism, and if it doesn't like its environment, it will escape and look for better climes. Now, it's very cute, but it's so much more than just a cute little yellow organism that grows in pretty patterns. Google Scholar cites over 27,000 academic research papers relating to slime mould. 27,000. Now, I don't have time to talk about 27,000 papers today, but I'm going to talk about two pieces of research that demonstrate why this is an interesting organism. You can read the other 26,998,000 in your own time if you wish. Okay, so one team in the Hokkaido University in Japan filled a maze with slime mould. It joined together to form this mass supercell. They then introduced food, porridge oats, at 2 points, here and here, and the slime mould locked onto the food and started forming a network between it, retreating away from the empty areas until it established a stable route between these two food sources. Now, there are 4 possible routes through this maze, and time again, the slime mould found the shortest and the most efficient route. So the conclusion from this research was that the slime mould demonstrates a simple, primitive form of intelligence. Another research paper, the research team invited the slime mould to explore an area scattered with oats. It branches out and explores, and as it finds the food nodes, it locks on and establishes a network between them. Over time, that network stabilizes. Now, there's nothing particularly unusual with this. This is what the slime mould does. This experiment becomes interesting when you learn that the starting point for the slime mould growth represents the city of Tokyo, and the surrounding oats are the suburban railway stations. The slime mould had successfully replicated the Tokyo transport system. A hugely complex network evolved over time through city dwelling, urban planning, civil engineering. What took us over 100 years to develop took the slime mould 26 hours. Since this experiment, the slime mould has mapped the world. Roads, railways, migration routes, trade routes, trafficking routes, evacuation routes, you name it, the slime mould has mapped it. I'm currently developing a project in London, a regeneration project. which is going to use the slime mould as part of the design team. And this is the first time this has been used. It's replicated lots of existing transport networks, but this is the first time the slime mould is going to be a fully paid consultant. So it is a biological computer. And as such, it has been mathematically modelled, algorithmically analysed, and routinely replicated. Michael, have you ever worked with slime mould? You should. Yet. So this is a computer model of the Tokyo experiment. This is a robot controlled by a living slime mould. The world over, researchers are decoding its biological behaviours and extracting the computational rules and applying that to very diverse areas of research. For me, as an artist, it's a fascinating subject matter, biologically and computationally. So I work in collaboration with the scientists, I take inspiration from the scientific research papers, but it's also my working material, a living co-producer in the creation of photographs, prints, participatory experiments. If anybody's in London on the 30th of August, I'm doing some slime mould workshops. You can take home your own pet. But it's a model and a metaphor. It's a way of, it's a platform for exploring questions about collective intelligence, knowledge distribution, communication systems. It's a way of looking at agency, intention, ideas of intelligence. So the question is, without any control centre, this is this bag of cellular slime, where does this intelligence lie? And for this, we'll take a closer look. So this is microscopy footage that I shot, and it's about 400 times magnification and sped up 20 times for your viewing. You can see within the cell structure, there's a rhythmic pulse, an oscillatory system that's flowing backwards and forwards through the cell, transferring nutrients and information about its environment. And this is where the intelligence lies, this continuous synchronous oscillation. All parts of the cell are working in perfect harmony. There is no control system looking down, but through local interactions and a constant feedback loop, this cell can communicate really quite complex information about resources, repellents, problems with its environment. So it demonstrates fantastic ability to communicate and to cooperate. Yeah, it's very simple. And it's very easy to kind of anthropomorphize. I mean, let's take this one, for example, a closer look. I hope you can see it on the slides. Just at a macro level, having fed on a nice pile of porridge oats, the slime mould goes exploring. When it meets itself, it stops, it pauses, it somehow knows it's already there. And it retreats and goes off to explore other areas. So this ability to navigate and to map its environment is very impressive. But this is, I don't want to project very human behaviours on this biological system. It's operating by its own rules. Rather than anthropomorphizing and asking how the slime mould is like us, I'm interested in flipping that. How, as individuals and as groups of individuals, could we improve certain skills by being more like slime mould? If we follow some very simple rules, will complex behaviours emerge? And this is the question that I want to put to you today. All I need is a group of people who are quite exploratory and curious, who are open-minded, dynamic, quite good at networking. Anyone got any idea where I could find such a group of people? Oh, looking at one here, aren't I? You're that group of people. Okay, just think about it. If a simple thing like a slime mould can demonstrate complex behaviours, what can a group of complex beings do? So we're going to conduct a biomimicry experiment. We are going to turn this room into a giant human slime mould mass superorganism. And that organism is going to navigate its environment and to test its capacity for communicating a feedback loop about what's going on in its environment. This is voluntary. You can observe from the sides. However, for this mass supercell to work, I do encourage mass participation. We need a critical mass. And I have done this experiment in different settings before, and always some interesting activities and observations emerge. But I have never done it in a room this size with this kind of mass of humans. So this is the real opportunity to test this principle. So are you prepared to test your ability to communicate and cooperate against that of a simple single-celled organism? Yes. Can we do that again? Are you prepared? This is going to get all panto. Are you prepared to test your ability to communicate and cooperate against that of the slime mold? Yes. Okay. Now you need some rules. And we need to cast a few people. Okay. Let me just run through the rules and then we will organise and then self-organise. Okay, rule number 1. You are a single cell. Okay, so your motivation in life now is to dispense with any ego. You are committed to being connected physically as one giant cell. Now, you can just, kind of hold hands or shoulders, whatever you're comfortable with, but we need to be physically connected. Because one very important rule is the slime mold has no voice. So the slime mold doesn't chat. Oh, there's an oat over there. Let's go see it. The slime mold communicates through oscillations and vibrations. So you're going to have to improvise some form of language that doesn't require voice. This goes back to the behaviours. When you're looking for food and exploring your environment, you branch in a fan-like, beautiful dendritic pattern. So we can see how harmonious and well choreographed you are. When you find food, and in this case it will be porridge oats, you're quite attracted to the people we're going to recruit as oats in a minute. So if you're feeling like you want to be loved by a giant human slime mold, we need 5 oats. So I'm going to ask for some volunteers to be oats in a moment. The next rule, if you encounter something that you don't like, in this case salt, you try to keep away from it. So we have attractants and repellents. So that means that some of you might be feeling particularly attractive today. Some of you might be feeling a little bit antisocial, a little repellent. So do we have some volunteers? Who's feeling like they want to be hugged by a giant slime mold? 5 people I need. Okay, this man here, if you come up. Lady there, man with the hat there. Yes, gentleman here. And one more who had, yes, over there. Okay, thank you. If you want to get with the oats and distribute those, that would be marvellous. Who's feeling like they're really antisocial and want to really hack off a giant human slime mold? Okay, one volunteer here, there, and let me see the one at the back because I'm being a little bit biased over here. There's a lady at the back there who's going to come up and be salty. Okay. Okay, I'm going to come down and give these guys their instructions. Whilst I'm doing that, we need to create room for this thing to happen. Okay, so pay attention. We're going to super efficiently, not superficially at all, super efficiently clear this room. So this is your first test of cooperation. Okay, I'm going to explain how we do it, and then you can do it yourself. So we're going to stack all the chairs and belongings from this row out. So in a moment, you'll stand up and just stack all the chairs to the side on these 2 sides, okay? In the middle, if you do it from the middle, stack the chairs and then just congregate them around the poles. What we want to do is clear as much floor space as possible. So if you could put belongings with chairs, then you know where they are when you come back to them. Okay, so self-organise, giant slime mold and observers. If you clear the room, and I'll come down and give you your instructions. And okay, I'm back on. So our oats have their instructions. Our salt line has their instructions. So in terms of these massive individual cells in the middle, you have demonstrated fantastic cooperation so far. This is the neatest kind of clearing in 2 minutes I have ever seen in my entire life. And it also helps the organisers because they don't need to clear up afterwards, so they're quite happy. Okay, what we're going to do is, in a moment, you're going to form a giant mass human slime mould. Okay, so this will just be kind of connecting. What we want is every part of the cell connected. Take a little while to get used to how that feels to be part of this big giant organism. Then we're going to introduce some food. So just as a reminder of the rules, you like oats. When you find an oat, you're going to stay attached to that oat and not let it go, even if it moves away from you, because you really, really, really like oats. Okay, and we're going to see what happens with the network as we introduce different food. And then we might introduce some things to interrupt that. When you've got some obstacles to navigate around, you know, you can break your connection. You don't have to stay connected to the same part of the cell. As you move around obstacles, you might need to reform. You're a shapeshifter. So you can reform and reconnect, but your motivation is to stay as one and to connect to the food. And we're going to see how much of a kind of optimal network you can actually create in 5 minutes. Okay, so when you're ready, human slime mold, connect, become one, and explore your environment. Yes, I was going to say, remember, you have no voice. But thank you, whichever part of the cell shushed, because that was encouraging. Okay, you're quite a curious organism, remember, so you want to go exploring. See if you can find some food. Oat number 1. Okay, hide your oats for now, because they're going to be... There's only one oat in the room at the moment. I'm introducing them slowly, so these are... Try not to rely too much on your vision. Try to think, how does one part of the cell that's near the food communicate to the rest of the cell? Oat number 2, over there. How does the cell manage to communicate if it has no voice? Are you feeling loved, oat number 1? Okay, number 3, at the back of the room. And 4 over the back, kind of other back as well. And we'll see how long it takes them to get you. Please do not accost oats when they're getting into position. Or at least if you do in a friendly way. If you have to break and reform, then you're going to have to recompute and rethink what you're doing. Problem solve. This is biomimicry in action. We have 2 slime molds. Okay, number 5 in the middle here. Good. Someone's noticed the new oat that's entered the arena. Are all parts of this cell in perfect synchronous harmony, do we think? Yes. Oh no, connection broken. Okay, so now just try to make it a little bit more difficult. Stretch if you pull out, we'll see, this is where you get to optimize and form, see if we can get the most efficient network. Think Tokyo transport system. Can you plan a complex network? Okay, salt, if you go break this bit here, and then they've got to try and work around you. So if you just go and send a little protest. Okay, so the salt has now cut off a part of the cell. What are you going to do about it? Okay, salt, hold your position. Beautiful. And let's see if we can reorganize the network. Can we reconfigure? Are we all connected? Or is the salt too much of an obstacle? Okay, let's see. Is this the most efficient form? I'll give you just 30 seconds to reorganize, and then we will assess the situation. You seem to feel quite well established. I'm seeing there's a kind of stable thing, and you took even less time. slime mold took 26 hours. You took 4 minutes. Fantastic. Okay, well, let's end the experiment there. Please give yourselves a round of applause. Thank you very, very much for being slime mold, for being game. Oats, you were very attractive. Salt, you were a great protest. We're just going to end the couple of minutes. Have we got a couple of minutes?
1 minute.
Okay, 1 minute of observation. So, I mean, clearly this is not a scientific experiment. It's not hypothesis-driven. I'm not trying to demonstrate or prove a particular point. But it is a means of engaging with biomimicry by embodying some simple rules. You only did it for a few minutes in a mass crowd without much preparation. But if you reduce to simple elements, there is something to be gained about how you actually communicate. How do you distribute knowledge through a group of people? And you can play that at whatever scale is important to you. Maybe it's about your organisation and hierarchical structures within your organisation. It could be within design teams and how you kind of physically respond, or in the market. It's a metaphor that can be applied in many different ways. I mean, I've done the experiment in different places. This was linked to the biodesign exhibition in Rotterdam, with the Financial Times Innovation Conference. So this was framed towards organisational structures. I also founded the Slime Mold Collective, which is an open online network for slime mold enthusiasts and researchers across the arts and the sciences and computational things. So we have a membership of over 500 people. So I told you the slime mold world is big. It's a small network, but it's growing. So if you're interested, do feel free to join the Slime Mold Collective. But yeah, I mean, do you have any observations from that brief little engagement with being biological in a different way, in a non-human way? Any observations that you'd like to make to end with? Yes?
Wait for the microphone, please.
Okay, it's a mic behind.
Yeah, it was surprisingly easy, but I would have loved to try it without my eyes open.
Yeah, that's the next stage, is to reduce your sensory sense, because in this environment as well, you're relying on, there's a note over there. And I have done it with people closing their eyes as well, and then they are really having to develop a different way of communicating than used to. Any other observations?
I felt that when there is an objective bigger than us, it was very easy to cooperate, and yeah, it went very natural.
Yeah, it certainly looked like it was easy to cooperate from where I was standing.
So, thank you so much for coming and sharing this with us. Heather Barnett. And as for you, we have hidden all the oats in the main theater, where the closing keynote is about to begin. So please go directly to the theater, and thank you very much.